Hi, it's me, Joe, again. I know it's been a while, and I've been meaning to do this for a while, but this is my Cisco Modeling Labs kind of on again, off again YouTube episode where we go through a cool feature, capability, or thing with Cisco Modeling Labs, with CML. The reason I said I've been meaning to do this for a while is it's something that we get asked about a lot within CML, and that is SD-WAN. The good news is as of CML 2.7, and the current release is 2.7.2, and we have a 2.8 right around the corner, we're shipping the SD-WAN images by default on the supplemental reference platform ISO. Uh, the, the images, I mean, we have the controller, the validator, the manager, the edges, all of that you can run within CML. So you can build out a full SD-WAN fabric. Prior to shipping those by default, I took it upon myself to test and make sure that, in fact, we could, without going and buying additional licenses, we could set up a full SD-WAN fabric in CML, actually do something useful with it. So I did. I went and built this. So makes use of our nice, cool little annotation feature, and I put in the manager, the validator, controller. I put in a couple of edges and some sites, some clients. Um, and I did all of this by hand, meaning I went in and generated certificates with OpenSSL, loaded those into the manager, defined the templates, onboarded the vEdges. And to do that, I had to go out to Cisco Software Central, the smart licensing portal, generate the bootstrap or onboarding files for them, load those into the SD-WAN manager, and get all of that going. That was a lot. It took a long time to get that set up, and I had to bounce between a few sets of documentation to do it. I do, however, recommend you do that. If you're trying to learn SD-WAN, if you're really serious about getting into it, it's a good exercise to do um, at least once and understand all of the moving parts that are involved there. And to kind of help you with that, in the CML documentation, we have under the images for CML labs, we have a Catalyst SD-WAN page, and it talks about some of that. Talks about how you can get this going using the documentation, walks you through getting the bootstrap files for the vEdges, the Viptela edges, this serial file .viptela that you can then onboard those vEdges if you want and um, get your fabric going. However, I could spend, and this video would probably go for an hour if I walk through all of those steps. But fortunately, there's a better way. One of the things that we link here, this Catalyst SD-WAN-lab on PyPy, is the pretty cool deployment tool for SD-WAN. So this is the command that we're ultimately going to do, and I'll show you how to go from zero to full-on fabric in a really short amount of time. And this is what I would recommend. Once you've got all the battle scars from setting up an SD-WAN fabric on your own, this is what I recommend you play with. And this was created by some Cisco engineers, TAC engineers, who needed SD-WAN, needed to spin up numbers of different fabrics for customers, and they built this really cool solution. I can't say enough good things about it. And once you see how this works, you're going to love it. That said, even with this tool, it does take a little bit of time, and that time will vary depending on your hardware to get SD-WAN going. So this video is going to stop and start a few times just so, through movie magic, you don't have to wait all of those real seconds and minutes for this to happen. So we're going to go ahead and install this, and I'll show you how we can spin up an SD-WAN fabric without doing any of the really heavy lifting that you have to do if you're going to do this by hand. So I'm going to bring up my Ubuntu environment here. I've already installed that package. If I do a pip freeze, I grep Catalyst, you'll see that I already have the Catalyst SD-WAN lab installed, and that installs a command line. I like the SD-WAN, short CSD-WAN for Catalyst SD-WAN. You run that, and yep, it's installed. You can see that we have the version that we just saw on the web page, 20.0.14. And there's really three sets of commands just out of the gate. There's others, and I highly recommend from here you can click on the like limitation scale. This will take you to the maybe well, it's all written here too. So this documents all of the additional commands. But don't worry, we're going to go through the important ones right here. So I'm in my Linux shell. This also runs on Mac OS. This also runs on Windows, but you need to install the Windows subsystem for Linux. But we're going to do it here on Ubuntu. The first thing we need to do is set the environment variables to point to our CML instance. So I've already done that. I've created this SD-WAN.sh file that I define some of the environment variables, including the IP address of my CML server. So it's the IP address of CML, nothing magic there, and an account capable of really has to be an admin account because the setup steps are going to do some more administrative level things. So I've just used the default admin and the password. I'll get to this bit in a second. This is kind of cool, but I'll talk about that in a second. This is going to be the user that we would use to log into the SD-WAN manager, and that's going to be the password. And I just pulled these two things out of the documentation here by default, the SD-WAN and, well, the GitHub page has this more complex password. But you can pick what you want and set that, and then you source it. So we have all our environment variables defined, so I'm going to source // actually, just so talking about that file, source that into our environment, so all these environment variables are now loaded in our current environment. That's step one. Now, I mentioned I'd come back to this manager IP address. You see, that's not really an IP address. Joe, what are you trying to pull? You can make that an IP address. If your SD-WAN manager can be connected to the bridge external connectivity in CML, so share the same layer 2 network as the CML VM, then you can certainly make that an IP address and you can directly access the SD-WAN manager that way. However, in my case, and maybe in some of your cases as well, you can't always do that. There's a feature relatively new to CML called PATI. And PATI allows you to do port address translation, so network address translation, the port variety of that, where you map a port on the external side of CML, in this case, we're mapping port TCP 2002 to a port inside one of the running topologies. There's more to this configuration. I'll show it to you when it gets spun up, but the SD-WAN tool takes care of the rest of it. So what we're saying is, in order for us to access the APIs of the SD-WAN manager, we're going to go through this port address translation, and we'll use port 2002 on the CML server IP, and that will map to port 443, the HTTPS port, on our SD-WAN manager inside. Again, I'll show you how that works. This way you don't have to burn another IP address, maybe you can't, on the CML subnet, and it all works very nicely. Bit of caution here though, PATI is disabled by default. So you'll have to go into Cockpit and you'll have to enable the viral to PATI service. Just turn it on in Cockpit, and then that's all you need to do initially. PATI will work, and this SD-WAN, Catalyst SD-WAN tool will take care of the rest. So we got our environment defined. We're going to use PAT. We're not going to have direct access to the SD-WAN manager running in CML, but we will ultimately have access. And now what I'm going to do is the first real step with the tool. That is called setup. Very easy. You don't have to do this every time. You just have to do this once. Technically, I've already done it, but I'm going to run it again. The setup step, make sure that the node definitions are loaded correctly in CML, and that everything otherwise looks good and is set to go. So I'll run setup. Task is done. Great. If you don't make any changes, if you don't need to load any additional images, you don't need to run this again. If you do, however, want to load images, you can stick the images here in the same directory as this when you run the script, and it will load those images into CML. But again, don't have if once you have things loaded in CML, you just run this once, never have to run it again if you don't want. So I've run it once. The big step, the step that's going to take the most time is this next one. That is the deploy. This is going to deploy the backbone or the infrastructure of the SD-WAN fabric. That's going to mean the controller, the validator, the SD-WAN manager, and it's going to set up the underlays. By default, there are going to be two underlays. It's going to be a business internet underlay and an MPLS underlay. And there's not a lot of magic there. They're just separated and called that way, and the tunnels are created in that manner, so you can get the idea of how SD-WAN works over these over different paths, so different paths to be able to connect your sites. So those two will be created by default. And this is depending on your hardware, because it has to spin all of those nodes up. This is going to take quite a bit of time. So I'll start the deploy. Oh, I need the software version. So I believe I have 20.9.4 loaded on here. So you can have multiple software versions. This is the version of the controller, the manager, and the validator should all be the same. So I do that, and it says, okay, I need a subnet mask. I didn't specify that. I can specify that in my environment. I didn't because I just, again, took the example off their web page, but /24 is what I want. It doesn't have to be much bigger than that. Remember, my SD-WAN manager is going to be behind a NAT. So it's going to use the default CML NAT. So my gateway is actually going to be that. And if you're doing the same thing, you can use these same values. 192, 168, 255, 1 is the default gateway that the NAT provides inside CML. That's the external connector of type NAT. That will be the default gateway. Since I didn't specify these two parameters in my environment, I'm going to have to do it here, but that's the rest of it I did specify. And now what's happening is it's waiting for the nodes to boot. And I called this particular topology SD-WAN with ease, because believe me, once you do this once manually, this is a lot easier. So let's take a look at what's going on in CML. So I'd already created one of these. That was my initial proof of concept. But you can see now SD-WAN with ease, that name is being spun up. And this is the default configuration, the default topology that it created. You can see it all cranking away on booting those nodes. You'll note here, though, there are no edges. So while we have kind of the infrastructure, the backbone of our fabric, we don't have any edges yet. That'll be the final kind of mandatory step that we're going to do once this all gets booted up. But in order for that to happen, we have to have the manager fully functioning, and that's going to take a while to boot. So if we go back over here, we'll see in the waiting the nodes to boot. Once the nodes boot, then it's going to try to connect to the manager many times. And even though the manager is booted, all of the processes, subsystems in the background of the manager need to come up, and the manager is fully ready to be logged into, and the script can continue its work. I'm going to go ahead and pause right here. I'll resume once everything is up, so you don't have to wait for all this to happen. And then there you can see it's trying attempt 1, so everything's booted. This will take a while. I'll see you in a few minutes. All right, so it completed. Took a little while, but then what it did, it deployed all of the basic templates, all of the basic config needed to get the fabric going. And then when it's done, it tells me, okay, great, lab was deployed. This is the URL to access CML, and this is the specific URL to access the SD-WAN manager. Because I'm jumping through yet another NAT, I actually have it loaded as mapped through SSH to localhost, same port though. So this is the SD-WAN manager. And remember, we had the user SD-WAN, and then we had a odd password. So I can cat that SD-WAN SH again. So we can get that password in, put that in, and we log in. I don't need to see that again. But we'll notice, like I mentioned before, there are no edges. So we really don't have much working with SD-WAN right now. We're going to have to add some edges to it. But the good news is we're able to log into the manager. We have everything running, all the green check marks. We're able to access the manager, and we see that things generally seem to be working okay. We see that we have a vBond, we have a vSmart, vManage, so we have the validator, the controller, and the manager, and we can click through and see some of that. But the next thing we're going to need to do is make this fabric actually work for us. And the way we do that is with the SD-WAN add command. So I'll just run it without any arguments so you can see what it's expecting. It needs a number of devices we want to add, the device type, and the software version. And it occurred to me that before I said I wanted to deploy version 29.4. This may not be the version you have in your CML. You can always go over to the Tools menu, Node and Image Definitions, and in Image Definitions, and you can see what available images you have. So for example, I have a Catalyst SD-WAN Manager 29.4, so that's the image that I wanted to deploy. You can also look at the node definitions. Got quite a bit of CPU utilization deploying this. You can also look at the node definitions. So I've got a SD-WAN Manager here, and you can see that this will also tell you the available image definitions. So I've got just 29.4. So that's what I deployed. But now we're going to get to the, let's go back. Now we're going to get to the edge portion. So we're going to deploy some Catalyst SD-WAN edges in here. And those are based on the Catalyst 8000V image. So the tool doesn't deploy the Viptela V edges. Those require additional onboarding through the Smart License Portal. You can do those manually, but we're going to have the tool deploy the regular Cisco edges, the C edges based on the Cat 8000V. With that, I have this image available. So I have a 171203A image available that I can use to deploy these edges. I'm going to go ahead and deploy two of them into this, and so I'll keep the window up there so you can see it. So, but first I'll run the add command. So number of devices 2. Device type is going to be the edges. So I'm going to deploy 2 edges, and I'm going to deploy the software version of 17.12.03a. So those are the positional arguments. Number of devices, device type is edges, software version is that, and I have to say what lab I want to do this in. So the lab, I'm just going to specify the title, which was SD-WAN with ease. So that's the title of the lab that I deployed, and I'm going to go ahead and spin this up. Now this is going to take a little while as well because those edges have to boot, but I'll go back here and you'll see, before I pause again, I'll show you that at least, see the edges start to get plumbed automatically. It's like magic. The edges get added, they get connected to the various types of connectivity, the underlays, the business internet, the MPLS, they get named, they get configured, and then they'll get spun up. So I'll go ahead and pause again, wait for them to get up, fully boot, get onboarded, and then I'll go back and we'll see how that looks in the SD-WAN manager. All right, so you can see it added both of those edges. They're fully booted, they're online, everything is good. Let's look at what the SD-WAN manager shows now. I will say though that even though the script completes and everything looks green and green good, you will take a little bit of time for the BFD sessions in the tunnels to fully stabilize and come up, but it will happen. But let's head back over to our overview here. We see that one has come up, one is unavailable. So if I go and I look at the devices, Edge 1 looks to be fully controlled and fully functional. Edge 2 is going to take a little bit of time. That's fully understandable. Again, based on hardware and resource availability, you can see my my cluster is a little bit overwhelmed with what I'm doing, especially because even though I have only one SD-WAN fabric running, I've got this other one shut down, but it is taking quite a bit of disk space. But this will continue to crank on through, and eventually we should see, if we go back to the overview of the monitor, we should see all of both the BFD sites, so both sites, I should say. We have two sites, site 1 and 2. We should see both of those go full with BFD, and then we'll have connectivity. In the meantime, what I want to do is add some. So we have the edges, we have the two sites. So edge 1 is site 1, and you can actually go and look at the day 0 configuration that was generated for this. So edge 1 was given site 1, and then over here edge 2 is given site 2. So we have two sites running, but we don't actually have any quote unquote users. We don't have anything behind them. So if you think of them like these sites as branch offices, you'd expect something to be in there, right? I mean, that's why you're connecting them with SD-WAN. So what I want to do is go ahead and add additional nodes. I'm going to add 2 Alpine nodes. They're just lightweight Linux nodes here. One in site 1 and one in site 2. So I'll create a link between Alpine 0. I'll put that Gigabit Ethernet 3 is what we want. On the edge, that's going to be kind of the inside, the LAN side that we want. And I'll do the same thing in site 2. So I'll connect those up. And then I'll go ahead and power them both on. Back over here, start that one. Alpine 1, start that one. The way that these are configured, these edges, and I'll go back to the edge here real quick and show you that. If you scroll down more, you'll see that there is a DHCP configuration. Find it here. There's a DHCP configuration on that interface that will hand out IP addresses inside to your network devices. This way, you can actually test that SD-WAN is working the way you expect. So let's take a look. These are already booted, so we'll jump onto the console of our Alpine 0 node here. Do an IP adder show, and we see, yes, we did get a DHCP assigned address, 192.168.1.100 over here, and we'll go on to the console on the other Alpine node in site 2. Do the IP adder show, and we got a 192.168.2.100 over there. So this is great. This is a good first start. I'm going to go ahead and enter sudo here and do a host name of Alpine-1 so we can see that that's Alpine 1 over here. I'll do the same thing on Alpine 0 over here. So now we see which is which. So now we have 2 nodes in each site, and we can send some traffic. We can test the various SD-WAN elements. But before we do that, just want to make sure that everything fabric-wise is looking good. Still, BFD on site 2 is just taking some time to establish, but we at least have our devices in place, and we can at least test some stuff out. So what I'm going to do, I'm going to pause again here. I'm going to bring up my other fabric because I've done some policies, I've done some configuration there, and I'll show you just testing the traffic so you can kind of get the idea of how this whole SD-WAN thing is working, and kind of walk you through how that happens and some of the cool features in CML that you're able to do to validate some of this. So bear with me for a few minutes. We'll pause, do some movie magic switcheroo, and then come back in. All right, so now I have the other, still created with the same tool, SD-WAN fabric up. You can see I still have an Alpine 0 and Alpine 1 node in there in my sites. If I come over to the SD-WAN manager, you can see that the BFD connectivity through our sites is good. We have full established there. We've also seen some traffic. And now I'm going to just show you. So we remember we had IP adder show Alpine 1, or Alpine 0 rather, site 1, got 192.168.1.100, and IP adder show over in site 2, 192.168.2.100. So if I go back to site 1, I should be able to ping 192.168.2.100 over to site 2, and I can. But what path is that taking? Well, let's take a look. We can use the good old traceroute command. We'll do a traceroute minus I for ICMP minus N so we don't resolve over to 192.168.2.100. And we can see that we're going through first to our default gateway, which is edge 1, 192.168.1.1. It's on the inside. Then we hit 172.16.2.2. Well, what path is that taking? Well, if I look at the console, if I connect to the console of Edge 1, login is admin, that's what it sets it up with, and I do a show IP int brief, we can see that 192.168.2 is on Gigabit Ethernet 2, and Gigabit Ethernet 2 is right here, and that's going up to the MPLS underlay. So it's going over MPLS by default. Okay, great. So now let's have some fun. So now what we're going to do is set up an extended ping. This is just validating. I encourage you to do lots more with SD-WAN. We're just going to barely touch the surface here. I'm going to do one of these extended pings again to 100. Here it goes. Everything's going well. Everything looks good. Remember, we're going over that MPLS backbone. In fact, on this other side, I'll do a while 1 equal 1. Do trace route minus I minus N 192.168.1.100 sleep 1 done. You can see here's the trace route going over the MPLS, the .2. But what happens if on this link I decide to disconnect it? I'm just going to disconnect the link right here. All of a sudden the ping stops working. Well, that's not good. We lost connectivity to our site. Oh, it started again. The link's still disconnected. See, we don't have green here. Why did it start again? Well, if we look over here and we look at the trace route, now we're going 172.16.1.1. So where is that? Well, if I look at that, 1.1 is Gigabit Ethernet 1 on edge 1. That's going up to the business internet. So this is the power of SD-WAN. It's picking now, in this case, the only available path. In order to complete the connectivity. So we still have branch to branch or site to site connectivity. And so we know now that SD-WAN fabric is working, SD-WAN magic is happening. So I'm going to go ahead and reconnect this link. Everything is good so far. We're still going over the internet. After a while, we should recover back over to our preferred path of MPLS. So it's going to take a little while, validate that link is up, and then we'll flip back. But disconnecting is not the only thing you can do in CML that's kind of cool. You can use this notion of link conditioning here, where you can set, forget the bandwidth for a second, but you can set parameters like latency, jitter, and loss to create a link that's less ideal. By default, everything in CML is like a gigabit Ethernet link, locally connected. It's like right there. It's healthy. It's going to pass traffic as fast as it can, as fast as the nodes will allow, given that gigabit Ethernet plumbing in the background. We don't have to always have it that way, though. What we can do is we can mess with some of these parameters, make the link a little bit dirtier. We can increase packet loss on the link and cause things to behave a little bit differently. And that's kind of nice when it comes to things like SD-WAN, because one of the things you can do is configure. This isn't done by default, so again, there's a lot that you can still do. The tool does an amazing amount in setting up your fabric, but you can also come over here and adjust or create policies on how you want traffic to behave. So if I do a view here and I have some application aware routing, here, let's take a look at what the policy actually kind of looks like. We'll do a preview of this and get this idea that we can, based on different things like jitter, latency, and loss, we can decide what we want our preferred tunnel or preferred connectivity to be. So here I have an SLA class applied to ops and admin, so ICMP traffic essentially. It would prefer MPLS, but if the loss in bulk data is above 8% packet loss, then it'll fail over to business internet. And that's kind of nice because if we have a bad quality of experience, the link may be up, we may be able to pass traffic, but it's not ideal. It's not what we want our users to be experiencing, so we can have SD-WAN recognize and fail that over. As you can see, at this point, it's recognized that the MPLS link is stable, and we've failed back over. Now our trace route is 172.16.2.1 as opposed to 1.1, so now it's going back over to MPLS. So I'm going to go in and put a loss factor of 10% packet loss on this link, on this MPLS link to site 1. I'll enable that, apply. We can see this icon means that link conditioning is enabled, and we're already starting to see some loss here in our trace route. If we go over to our ping, we're going to start seeing about 10% loss here. We're going to start seeing, see 281 to 283, and we'll start seeing more of that loss. And as SD-WAN, as the controller gathers data, it gets processed, or as the edges see see this problem, they're going to apply this policy. They're going to say, okay, it looks like we're losing sustained loss of about more than 8% of our traffic. We want to adhere to the policy, and we want to prefer a different route. So this will take a little bit of time because it obviously you don't want things bouncing back and forth wildly. You want to make sure that yes, what we are seeing is sustained loss, and so we don't keep going back and forth. So as we continue to see this loss, we'll continue to go out over the MPLS path, but we should see after a little while, we should see that this falls over back to the business internet. And one of the things you can do here in the SD-WAN controller is go into tools and look at like operational commands, or you can go into monitor and you can just say, I want to monitor the devices. Let's say I want to monitor in real time edge 1. So I'll pick edge 1, I'll come down here to tunnel, and I'll say real time, and we can start to see what the various loss parameters are for the business internet and the MPLS link. So as this starts to build data, you can see that already it's registering some amount of loss on the MPLS side, and business internet is showing 0 loss. So like I said, eventually it will figure out that, hey, we've got the sustained loss here, and we should start to see this ping smooth out, meaning we shouldn't see any drop pings over here. And when that happens, if we go over to the trace route I'm running on the other side, we should then see that it's taking the internet path. And we can continue to watch here what are still taking MPLS. We can continue to watch here. But again, it's going to want to make sure that everything is smooth and consistent, and we're adhering to our policy. That's, again, how you can validate that some of this SD-WAN is working. But this isn't really what I wanted to do here was kind of just introduce this SD-WAN tool, get you excited about it, get you from, like, if you're thinking, I want to do something with SD-WAN, but it just takes forever to get a fabric set up, that's where this tool comes in very handy. And as you can see, I'll go back here and I'll show you that I now only have the one SD-WAN with ease lab that I set up. I don't have the other one. This was my initial one, just renamed it from test SD-WAN with ease. The tool also provides an ability. You can see here a delete command. So we didn't go through some of the other commands. Add was really where we stopped for adding the edges, but we can delete labs as well. So I had specified before I resumed my last pause, I deleted the previous lab, the one we just created. So you can delete, create, add, and then once you get these up, you can do all sorts of things with them and continue to modify them. There are other commands like being able to back up and restore. So you can back up all of the policies, all of the templates that you've done with a lab, and restore that later on if you have like multiple people using CML and you want to be able to test that. Let's see if we've completed our failover exercise here. We've got ping looking, maybe. We've got no loss. Did we get 10 through without a loss? Looks like we did. Let's take a look over here at our trace route. And yes, we can see that we are now going back to 172.16.1.1. So we're going back over the business internet side. Yay for SD-WAN magic. And then you can always disable link conditioning. So I'll reset link conditioning, and eventually, and I won't bore you with all that time it takes, it will fail back over to, or switch back over, I should say, the MPLS side, which was the initially preferred um, element for, or connectivity underlay for the traffic to take. Whew, that was a lot. I hope you got something out of it. Remember, it all starts with this Catalyst SD-WAN-lab tool. So pip install Catalyst SD-WAN-lab, and then it's up to you. Get creative, learn SD-WAN, understand it, play with it, get comfortable with it. And if this is your first time, I do recommend you take a look at this documentation, the getting started guide, the bring up process. It is involved, but it will give you those battle scars. It will give you the appreciation for all the moving parts that are required for an SD-WAN fabric. Let me know what you think. Let me know if there's something else you want to see. I hope this was useful. Thank you very much.